Alright, this is transformations questions from Power School that we're going to go over now. This is the non-calculator video, so this is good though. You don't really need a calculator too much on these problems. It could help, but probably better without it anyway. Alright, but looking at number one, we're given this line here, this curvy little line. And we're asked which transformation best describes the graph below. So this is what we're starting with here, is this graph, and it's moving to this position. So how did it move? Did it shift down 2? Did it shift right 2? Did it shift up 2? Or did it shift left 2? Well, just pick any point and see where that point went. I think the most obvious point is the one here on the y-axis. It was at 1 originally, and now it's at -1. So it seems as if that point has been moved down 2. Now you can't always rely on that, but that's how I think best. It is most obvious here. You can see that this one levels off right above 0, but here it levels off right above -2. So everything about this line seems to have been moved down 2. Alright, so option 1 would be our answer. So if the slope, let me see if I can zoom in a little bit more here. Alright. If the slope y equals 2x plus 5 is changed to -2, how does the graph change? So this goes back to some old school knowledge, but let's imagine, we don't really have to imagine a graph, I guess. Kind of could. But the original equation y equals 2x plus 5, it's asking us what would happen if we changed the slope to -2, which means it'd be a -2x plus 5. So all we're changing is basically making this negative here. Now how does that negative affect our graph? Okay. Here's the things that let's quickly kind of review, I guess, before we get to dive into this too much. We did our notes over this once, and we talked about all different types of transformations. So I'm going to review real quick, like I said before, going over this question. So we mentioned something like this: f of x plus k. We said f of x plus k inside parentheses. We had what was the other ones? We had we had oops, okay, I'm making too much now. All right. Hold on a second. We had f of x plus k. We had k times f of x, and then we had negative f of x. So basically, f of x means like the normal thing, and then the k is the change that's being made to it. So notice this k is being changed, it's being added. It could be subtracted, don't get me wrong. Outside of this function, outside of parentheses, whatever. That indicated to us a vertical shift, meaning it moved up or down. It'd be moving up if you were adding, it'd be moving down if you were subtracting. This plus k inside the parentheses means it's inside our function where the x is. Now, this moved it horizontally, this moved it left or right when we saw this number being added into the parentheses or inside our function. Now, it'd be moving left if it was plus k, it'd be moving right if it was minus k, which I remember seems a little bit backwards, but that's how it is. You kind of have to not lose sight of that one. Now, if you're multiplying a number to your function, that stretches it, makes it wider or narrower. So we call that a stretch. Remember, it would be wider or narrower. And then negative f of x means you're adding a negative to this means it flips over. So let me give you some examples, I guess, next to these. So if your function was, let's say, x squared, right? You had y equal x squared. Adding a k outside of it would be something like adding a 3 over here. Right? That would tell me that this function would be moving up 3. Using the same function, but what if we put the 3 with the x? Right? We do something like this and then square it. So the 3 is literally inside the function. That would give me a horizontal shift. Because it's plus, that means that that function would be moving left 3. this kf of x would be something like this, where you have 3 in front of the x squared, right? You're multiplying 3 to that x squared. That would make this stretch. And I think in this case would actually make it a little more narrow. In the last function, you don't have any 3, you're just making a negative. Instead of having x squared, you would have a negative x squared, and this flips the function upside down. So those are the 4 big transformations. Those are the ones that I hope you have written down, because we'll be coming back to this information a lot throughout this video. All right, but going back to our question number 2 here, if we change the 2x to a negative 2x, what have we done? We've made this negative f of x function, something kind of like this down here, which means we're flipping it over. So let's see which answer choice best sort of says flipping over. The graph is more vertical. That's not true. That would indicate more to me like a stretch in a way, if it was more vertical, which basically means more straight up and down. The graph does not change. Well, that's clearly not the case. The graph is more horizontal, which is sort of the same thing as more vertical. And then the graph slants the opposite direction. It's definitely going to be option 4, because that opposite direction is sort of my kind of code word for flipping over. So it's definitely option 4, because opposite directions kind of means the same thing as flip, right? Opposite way, flipping over, they sort of have the same relationship. All right, so don't forget those transformations. We're going to be coming back to them a lot. Now, probably, I wish I could just copy and paste them, but I don't think I can here. But I'm gonna want to come back to those all the time for this. All right, describe how the graph y equals x plus 5 squared minus 2 differs from y equals x squared. So notice the 2 changes in these. You have the plus 5 inside the parentheses, which tells me it's a horizontal shift, which means it's either moving left or right. Horizontal shift. So remember, that's the f of x plus k that I had mentioned previously, where I said if we had plus k, it's moving to the left, and if we had minus k, it's moving to the right. So having this plus 5 on the inside of my parentheses tells me that we're moving to the left 5. So let's make a note of that. All right, and now let's also look at the minus 2. That's another change here. This minus 2 is outside the parentheses. It's technically being subtracted, but it's tacked on at the end of this function. This represents to me, let's use a different color so we can kind of make it distinguished here. This represents to me a vertical shift, which, remember, that's up or down. Previously, earlier in the video, I wrote this as f of x plus k. Notice the k you see. The difference is, up at top, it's inside the parentheses. Here it's not. That's exactly what's going on with this minus 2. It's not in parentheses. And I mentioned that if it was plus k, it'd be moving up. If it was minus k, it'd be moving down. So we have a minus 2. So that's telling me it's moving down 2. So here we go. We got these 2 things. It's moving left 5 and then down 2. So which answer says that? Option 3, it looks like. 5 units to the left and 2 units down. Yep. That's how you tell. Okay, that's how all this whole video is going to be based off of those 4 different types of shifts. The vertical one moves up or down. The horizontal one moves left to right. The stretching of it, or the flipping of it. So this one is very similar to the last equation, or the last question. You have x cubed and it's transformed into x minus 3 cubed. So let's identify the key difference. The key difference is this minus 3 here. That minus 3, notice where it is. It's inside parentheses. So again, this is based off of this type of shift where you're putting this number inside the parentheses. This is your, again, horizontal type of shift. It's going to either move left or right. And just to repeat myself over and over again, plus k means it moves to the left, and then minus that number means it moves to the right. So we have a minus 3, so it would mean it's moving to the right 3. All right, so there's your answer. All right, almost exactly the same question again. We have the square root of x, and it's changed to the square root of x plus 2. It's very important that you realize here, though, that this 2 is inside the radical sign, just like the previous questions were inside parentheses. The fact that this 2 is inside the radical sign means it's inside the function. It's based off of this type of shift again, one of those horizontal shifts. Okay, it's moving left or right. If this looked more like this, where you see the 2 is not inside the radical, that would be a more vertical type shift. That would move up 2. But because it's inside the radical, it's moving horizontally. It's moving either left or right. Remember, again, just to repeat myself again and again, plus k is left, minus k is right. So since we have plus 2, that means we're moving to the left 2. All right, so there's your answer. The graph of the equation y equals x is translated up 6 units. What is the equation of the new line? All right, so this one's kind of like the same as the previous 3 or 4 questions, but it's kind of worked itself backwards in a way. All right, so we have y equals x. Not plus, hold on a second. We have y equals x. Now, it says it wants to move up 6. Up 6 means a vertical shift. Right? Moving upwards is moving vertical. So remember, vertical shifts are the f of x plus k. So this 6 is not going to be inside any sort of parentheses. This 6 is going to be outside the function. So what we need to do is basically just add this 6 to the very end here. Now remember, plus k means up, minus k means down. So since we want to go up, we're going to be using plus. So we'll just have to add the 6 to the end, and we'll have our equation. That's it. All right, this graph is kind of, let me see if I can zoom out a little bit here so I can see it all. Very similar, again. But let's talk about what is the equation for this line. So we're going to have to look to see what type of transformations it made. Now, one thing you want to know, this is one of those you just kind of have to, I guess, remember, one of these facts, is that all these functions will start from 0, 0. Originally, this function was here, right? That center point, the tip of the v, used to be at 0, 0, but now the tip of the v is over there. So now we have to figure out how did it get from 0, 0 to where it is now. Well, it looks like it had to have moved to the right. Looks 3 units. And then it would have also have needed to gone up 2 units. So I'm looking for one of my answer choices to tell me it's moved to the right 3 and up 2. So this up 2 is a vertical shift, of course, and then right 3 is a horizontal shift. Remember, horizontal shifts means that this function, this number would be added or subtracted inside the parentheses. The vertical shifts mean that this number would be subtracted outside the parentheses. Don't forget, just repeat myself one more time, plus means up, minus means down. And for horizontal, plus means left, minus means right. So I need to go up 2, which means I need to put a plus 2 on the outside. And I need to go right 3, which means I need a minus 3 on the inside. So the only option that says a minus 3 on the inside and a plus 2 on the outside is option 1. So option 1 would be your answer here. All right, but you have to kind of remember these facts, the vertical, the horizontal. Those are just one of those things you want to have memorized for our exam. All right, this one I need to backtrack a little bit here, kind of review something again with you guys. It's what is the parent function? Now you don't have to overthink this, but you do need to know what parent functions look like. Parent functions are the most standard functions. For instance, let me just kind of make a little sketch of a graph here. I know there's one already there, but I'm going to make my own because I'm cool like that. Okay? Alright, so here's a graph or whatever. Let's use red for quadratic. A parent function of a quadratic is that parabola, again, that starts at 0, 0. Okay? So that's your quadratic. That would be y equals x squared. Let's use a different function in blue. An absolute value function is a v-shaped function, not a u-shaped, but a straight line v function. That's an absolute value function. So that would look like this. Let me choose another color. A square root function has sort of an arch to it, something like this. That's a square root function. Y equals the square root of x. That's what that function would look like. It'd have a square root in it. Okay? So quadratics have an x squared. The absolute value or v-shaped functions have the absolute value bars. The square root function has that square root in it, and that's what it looks like. What's another one? There's a couple more. Let me try to use a different color so we can see pretty well. Let's use the pink one. Another function is the exponential function. So the exponential function will look something kind of like this. Where, I mean, we saw a problem like, I think the very first problem we went over looked something like that. And that would be something where you have, basically, x is your exponent. So you have some numbers put there. But the main thing to mention with that is that the x, the variable, is an exponent. It's not x to some power, it's something to the x power. Alright, so those are, I think, the four main ones you need to know. I kind of put them all together, but you can kind of see all the differences. So looking at this graph, we have in ours sort of this arch shape. That arch shape looks very similar to my square root function. Alright? So that's how we know. There we go. The option 1 is our correct answer because that's what a square root function looks like. If you're wondering for any of these other ones, this cube root function, I don't want to be wrong, but I think the cube root function looks something kind of like this. And then this is a rational function, that number 3, option choice 3. And that function, I might be a little bit off here, but looks something kind of like this. Alright, and of course we already know the x squared is that parabola shape that we've already mentioned. So if you're wondering what the other ones technically would look like, they would look like that. Of course this one has that arch shape, that's the square root function. So just know these different shapes basically, be able to associate them with their different types of functions. Alright, so which represents this equation here? Which graph represents this one? Alright, so notice the transformations. Remember, these always start at 0, 0, but let's see what's happened here. I've got a plus 2 on the inside. Remember, that's horizontal. And if you've been keeping up, plus 2 means left. 2, because plus means left, minus means right. Also, let's point out that we have a plus 1 on the outside. That tells me a vertical shift of moving up or down. Remember, if you're keeping up here, plus 1 would mean up 1. So I'm looking for a graph where if I start at 0, 0, I move to the left 2 and up 1. So if we start 0, 0, we go left 2 and up 1. Well, it looks like it's this one. It looks like it's option 1. Well, let me just look at the other ones to make sure, of course. This one, left 2 and up 1. Yeah, definitely not there. Left 2 and up 1. Definitely not there. And then, of course, left 2 and up 1. Definitely not there. I'm looking for the bottom of the V, which, of course, option 1 has it. When I go left 2 and up 1, I hit the bottom of my V, and, of course, get that perfect match that I'm looking for. Alright, this is multiple select. There are more than one correct option here. Here's how you can tell. It says identify each function that has transformed the parent function horizontally 3 units. So identify each means that there's probably more than one. So we have an absolute value function. The graph is not really that important here. What's important is that we're looking at horizontally 3 units. Remember, a horizontal shift means that I have some kind of shift inside my function, inside my parentheses or whatever. Now, since we have absolute value, that means it's inside the absolute value bar. So I'm looking for a 3 inside, adding or subtracting inside my absolute value bar. So it's definitely not g of x because the 3 is on the outside. It's definitely not t of x because the 3 is on the outside. H, P, and Q all have 3's on the inside. But P is being multiplied. Now I'm not multiplying the k with the x or that 3 with the x. I'm adding it to the x. But again, it could be adding or subtracting. It's not P of x either. The answer is H of x and Q of x because minus 3 would move it right. Oops, right 3. And plus 3 would move it left 3. Either way, both of these move it horizontally. One of them moves it to the right, the other moves it to the left. But either way, we still accept moving horizontally. So those would be the 2 answer choices. All right, that's going to cover it for this video. We'll see you in another one. Sayonara, guys.